Welcome to Orbit Observer. Settle in. Wherever you are right now, whatever kind of day it was, you can let it be finished. You don't have to hold on to any of it anymore. Loosen your shoulders, let them drop away from your ears, and let the back of your head grow a little heavier against the pillow. There is nothing you need to do for the next while except breathe and listen and drift. I'm going to tell you a slow story tonight, a true one, about two small worlds very far away, and about a kind of danger that turns out not to be a danger at all. And by the time we're done, or by the time you've fallen asleep somewhere in the middle of it, which is perfectly fine, I hope you'll feel the way I feel about it, which is calm, steady, a little bit in awe. So let me set the scene. Gently, imagine you could leave the warmth of your room and travel outward, past the moon, past the red dust of Mars, out across a great deal of cold and quiet dark, until you reached a planet with rings. Saturn, you've seen the pictures, the pale gold globe, the flat bright bands circling it, tilted just so. Now imagine drawing close to those rings, and then a little past their outer edge, to a place where two very small moons are travelling around the planet together. They are called Janus and Epimetheus. And they are doing something that no other pair of worlds we know of does. They are sharing a single path around Saturn, running along almost exactly the same track. So close together that the gap between their two lanes is narrower than either moon is wide. And every 4 years, without ever touching, they trade places. Let that sit for a moment, because it sounds impossible. 2 moons, 1 orbit, less than their own width between them, and for as long as they've been out there, which may be a very, very long time. Longer than there have been people to look up and wonder, they have been closing in on each other, gaining a little ground year after year, drawing nearer along that shared road, and they have never once collided. Not once. Not ever. Now, if you're the kind of person who lies awake at night with a mind that likes to run ahead and brace for the crash, and I think a lot of us listening are, then something in you may already be leaning forward, waiting for the bad part, waiting for the moment where these two objects finally meet and it all goes wrong. I understand that feeling more than I can say. The mind reaching out into the dark, checking the locks, running the disaster before it can happen. But here is the first thing I want you to know tonight. And I want you to hold it loosely and let it soothe you as we go. There is no crash coming. There never was. The very thing that looks like an oncoming collision is, up close, one of the gentlest and most courteous acts in the whole solar system. These 2 moons are not survivors of a near miss repeated over and over by luck. They are partners in a dance so precise, so self-correcting, that the collision was never actually possible in the first place. What looks like danger is the safety mechanism itself. We'll get all the way to why, slowly, together, for now. Just let it be true, and let it be reassuring. Before we go deeper, I'd love to know where you're listening from tonight. If you feel like it, leave a little note in the comments telling me where in the world you are, what city, what time it is where you're lying there in the dark. I find it quietly wonderful to picture all of us scattered across the planet, in different beds, under the same handful of stars, drifting off to the same slow story. And if you're new here and you'd like more nights like this one, you can subscribe softly. No rush, and I'll keep making these for you. That's the only thing I'll ask of you all night. Now let's go back out to Saturn. I want to correct something first, because I care about telling you this straight, and because the honest version is actually more beautiful than the exaggerated one you may have heard. You'll sometimes hear it said that Janus and Epimetheus pass within 50 kilometers of each other. 50 kilometers. That's a short drive. And people say it to make your stomach drop, to make it sound as though these two moons go skimming past one another by a hair's breadth, close enough to graze, every single time. But that's not what's happening. And the truth is kinder. That 50-kilometer figure isn't how close the two moons come to each other at all. It's the difference between their two orbits. It's how far apart their two lanes sit, measured from the center of Saturn. One moon travels a track about 50 kilometers wider than the others. That's the gap between the roads, not the gap between the travelers. And yes, 50 kilometers is genuinely less than the width of either moon, which is a strange and lovely fact all on its own, that their two lanes are closer together than the moons are big. But the moons themselves? The moons themselves never come anywhere near touching. At their very closest, when one is gaining on the other and the swap is about to happen, they still stay something like 15,000 kilometers apart. 15,000. That's a real distance. To give you a sense of it, our own moon sits about 384,000 kilometers from Earth. So when Janus and Epimetheus come as close as they will ever come, they're still much farther apart than that 50-kilometer number would ever suggest, though closer to each other than we are to our moon, close enough that each would loom large and pale and cratered in the other's black sky, a great silent companion swelling into view, but never close enough to be in any danger. And here's the heart of it, the part I love. The reason they stay 15,000 kilometers apart at closest approach is the swap. The exchange is exactly what stops them from ever getting nearer. They feel each other coming, they hand over their orbits, and they turn away, tens of thousands of kilometers apart, long before proximity could ever become a collision. The distance between the tracks is tiny. The distance the moons keep is vast. And the dance is what keeps it that way. So when someone tells you these two worlds skim past each other by 50 kilometers, you can smile in the dark and know the real story, which is gentler and stranger both. Their paths run closer together than their own bodies are wide. And yet they always turn back with a comfortable ocean of empty space still between them. A collision that the geometry itself forbids. Not a lucky escape, a law. We'll come to exactly how that law works. But first, let's just be here for a while, out at Saturn, and let me paint you the place, because it's about the most peaceful place I can imagine falling asleep beside. Saturn is far. Really, genuinely far. It circles the Sun at about 9.5 times the distance the Earth does. In plain numbers, that's roughly 1.5 billion kilometers from the Sun. And light and warmth thin out the farther you go, so out at Saturn the Sun is no longer the great warm lamp we know. It's a small, brilliant point, still the brightest thing in the sky, but shrunken, distant, and cool. Saturn receives only about 1% of the sunlight that falls on the Earth. 1%. Imagine dimming the whole world down to 100th of its brightness. That's the kind of soft, low, silver light these two little moons live in. Not darkness exactly, but a permanent, gentle dusk. And it's cold out there, wonderfully, deeply cold, the kind of cold that has nothing to do with you and asks nothing of you. Out at the orbit of Janus and Epimetheus, the temperature hovers somewhere around 180 degrees below zero on the Celsius scale. Nearly 290 degrees below zero if you think in Fahrenheit. These are numbers so far beneath any cold you've felt that they stop being frightening and just become part of the stillness. Nothing moves quickly out there. Nothing is warm. Nothing is in a hurry. It is a slow, dim, quiet corner of the solar system, and I find something enormously restful in that. All that cold, patient space, just holding these two little worlds as they go around and around. And they do go around. Let me give you their orbit, because the rhythm of it is soothing in itself. Janus and Epimetheus circle Saturn at a distance of about 150,000 kilometers from the planet's center. 151,450 kilometers if you want the fuller number, though you don't need to hold on to the exact figure. What matters is the feel of it. They orbit just outside the main ring system, skimming along the edge of that great bright disk, out past the last of the bold bands, where the rings thin into fainter, ghostlier stuff. And they move quickly, in their own terms, even though everything about them feels slow. One full lap around Saturn takes them only about 16 hours and 40 minutes. Less than a single Earth day. A whole year for these moons, one complete journey around their giant planet, is shorter than the night's sleep you might get if you were lucky. Think of that. By the time you wake up, they may have gone all the way around their world and started again. Around and around, 16 hours and 40 minutes at a time, in the cold and the dim silver light, endlessly, without effort, without strain. Held by nothing but gravity, the same quiet force holding you right now against your bed. There's a comfort in that, I think. That the same simple law keeping those two moons on their long, calm loops is the very same law keeping you gently pressed into the mattress, keeping the water in the glass on your nightstand, keeping your own slow breath rising and falling. Gravity doesn't get tired. It doesn't forget. It just holds and holds and holds. Now let me introduce you to the two moons themselves properly, because they deserve to be known, and because picturing them clearly is part of what will let you drift. Janus is the larger of the two. Though I want to be honest, larger is a relative word out here. Janus is not a great round globe like our moon. It's a small, lumpy, irregular body, more like a battered potato or a rounded stone than a perfect sphere. If you measured it along its three different axes, its length, its width, its height, you'd find it stretches about 203 kilometers one way, 185 kilometers another, and 153 kilometers the third. On average, call it about 179 kilometers across. So, a small world. You could drive across it in an afternoon if there were roads and air and a car that ran at nearly 200 degrees below freezing, which there is not. But on the scale of moons, Janus is modest. A little lopsided mountain of a place, tumbling along its bright orbit. And Epimetheus, its partner, is smaller still. Epimetheus measures roughly 130 kilometers by 114 by 106, which averages out to about 116 kilometers across. So if you set them side by side, Janus would be noticeably the bigger of the two, maybe half again as wide, a broader, heavier shape beside its smaller companion. Both of them lumpy. Both of them irregular. Both of them small enough that if you stood on one, the horizon would curve away close and sharp, and the sky would be huge and black and full of stars, with Saturn hanging enormous and gold and ringed off to one side, filling a great swath of the heavens. Now here is something about these two moons that I find genuinely tender, and it's a detail that changes how you picture them entirely. They are not solid stone. They are not dense, hard, heavy worlds. They are, both of them, extraordinarily light for their size. If you measured their density, how much matter is packed into how much space, you'd find it comes out to around 0.6 of a gram per cubic centimetre. And that number means more than it might seem, because water, ordinary water, has a density of 1 gram per cubic centimetre. So Janus and Epimetheus are less dense than water, lighter than water. If you had an ocean big enough and you could somehow drop these moons in, they would, in the strange arithmetic of density, want to float. And the reason they're so light is that they aren't solid all the way through. They're what astronomers call rubble piles. Loose, gentle heaps of ice and rock, held together lightly by their own faint gravity, riddled through with empty space and gaps and hollows. Not a single hard boulder of a world, but more like a great drifting mound of frozen debris that has settled together over ages into a rounded shape. Picture a snowbank more than a stone. A loose, cratered heap, soft in its structure, quietly holding itself together in the cold. And both of them are covered in craters, marked all over by the slow rain of impacts across the eons, and cushioned under a smoothing layer of loose dust and grit, what's called regolith, a fine blanket of broken material lying over the surface, softening every edge. So when you picture Janus and Epimetheus, don't picture hard, sharp, dangerous rocks hurtling at one another. Picture two soft, cratered, dust-covered heaps of ice and stone, lighter than water, drifting along their shared path in the cold silver dark, in no hurry at all. There's one more thing I want you to know about how they move, because it adds to the stillness of the picture. Both moons are what we call tidally locked to Saturn. That means each of them keeps the same face turned toward the planet at all times. The way our own moon always shows us the same face and hides its far side. As Janus goes around Saturn, it keeps one side pointed inward, toward the great golden globe, always, and Epimetheus does the same. Their long axes point roughly toward the planet, and they hold that pose all the way around their orbit, turning just once on their own axis for every lap they make, so that Saturn stays fixed in one part of their sky, never rising, never setting, just hanging there, enormous and patient, and always in the same place. Imagine living on a world where the giant ringed planet in your sky never moved, never changed its position, just presided forever over one half of your little world, while the other half never saw it at all. There's a kind of steadiness to that, a lockstep gentleness that fits these two moons perfectly. Everything about them is measured, everything about them holds its place. So that's the setting. That's who our two travellers are. Two small, lumpy, dust-cushioned moons, lighter than water, deeply cratered, each keeping one quiet face towards Saturn, circling their giant planet once every 16 hours and 40 minutes, out in the cold and the thin silver light, 1.5 billion kilometres from the sun, sharing a single path around the world with less than their own width between their two lanes, and closing on each other. Always, slowly, closing. Now I've told you, they never collide. I've promised you there's no crash coming, and I mean it, and we'll get there. But I want to be honest with you about why this is such a good puzzle, because the wonder of it is part of what makes the answer so soothing when it comes. So let me open the question fully, and then let me set it down gently beside us, and we'll walk toward the answer slowly, over the rest of our time together. Here is the puzzle. Two moons share almost exactly the same orbit, but almost exactly is not exactly. One of them travels on a track just slightly closer to Saturn than the other. And there's a rule about orbits, a very old and very reliable rule that says the closer you orbit, the faster you go. A moon on an inner track moves a little quicker than a moon on an outer track. It has to. So the inner moon, the one just slightly nearer Saturn, is moving a touch faster than its partner, and because it's faster, it slowly gains on the outer moon. Little by little, lap after lap, it closes the distance along the track. Not quickly, it takes about 4 years for the inner moon to catch up to the outer one. But it does gain. It draws nearer. The gap shrinks. And this is exactly the moment your anxious, watchful mind, the mind that lies awake bracing for the worst, wants to seize on. Because if one moon keeps gaining on the other along the same path, if it keeps closing that gap, 4 years of patient catching up, then surely, one day it catches all the way up. One day the faster moon runs right into the back of the slower one, and 2 worlds of ice and rock, each over 100 kilometers across, meet, and that would be a catastrophe. That would be the crash your mind is waiting for. But it never happens. It has never happened. For as long as these 2 moons have been out there, which may be billions of years, the inner one has gained and gained and gained, closed the distance again and again, and never once caught the other. And for a long time, that was genuinely a mystery to the people who study these things. How can one object keep gaining on another on the same track over and over for eons and never ever catch it? What stops them? What turns the faster one aside every single time right before the moment of contact? What could possibly be so reliable, so perfectly timed, that in all that vast stretch of years it has never once failed, never once let the 2 moons meet? I want you to hold that question tonight, but hold it lightly. Not the way you'd grip a worry, tight and cold, turning it over and over. Hold it the way you'd hold a smooth stone in your palm, just resting there, its weight familiar and calm. 2 moons closing in for billions of years and never touching. Why? What keeps them safe? Because the answer, when we come to it, is one of the most reassuring things I know. The answer is not that they get lucky over and over, forever, luck runs out. Nothing gets lucky for billions of years. The answer is that something in the shape of the thing itself, in the geometry, in the physics, reaches out at exactly the right moment, every time, and gently turns them away from each other. Not by chance, by law, by the same dependable arithmetic that keeps the planets on their paths and the tides on their schedule, and you, right now, resting safely in your bed instead of drifting off into the ceiling. And there's more than one mystery riding along on this quiet orbit, so let me plant a few more seeds while we're here, and we'll return to each of them slowly as the night goes on. Because part of the pleasure of a story like this is knowing there are gifts still waiting further along the path. Here's the second thing to wonder about. One of these 2 moons spent 12 years hiding. 12 years. When astronomers first started noticing something at this orbit, they thought they were looking at a single moon. Just one. But the more carefully they watched, the less sense it made, because this one moon seemed to be in places it couldn't possibly be, appearing where a single object simply could not appear. Something didn't add up. And the reason it didn't add up is that there were never one moon out there. There were always 2, sharing the track, so close and so alike that for over a decade they were mistaken for a single body. One of these moons, in a sense, was overlooked, missed, hidden in plain sight, along the very same path as its twin. We'll come to who finally figured it out, and how, and to the almost too perfect name that Moon ended up with, a name that means, of all things, afterthought. But hold that too. The moon that was nearly missed. And here's a third small wonder to carry with you. Somewhere out along that shared orbit, there is a faint ring, a thin, delicate band of dust circling Saturn right where these two moons travel. And nobody put it there. No great event placed it. It's a ring the moons themselves made, quietly, without meaning to, just by being what they are and doing what they do. We'll come to how later, and it's one of my favourite parts. For now, just know there's a ring out here that no one placed on purpose, and that the two moons at the centre of our story are, in a very real sense, painting it as they go. And here is a fourth thing to wonder about, maybe the gentlest of all. When the two moons finally do their 4-year exchange, when they reach each other and hand over their orbits and turn away, they do not move by the same amount. One of them shifts a great deal, the other barely stirs. And there's a reason for that, a fair and simple reason rooted in the fact that one moon is heavier than the other, and I'll explain it all in time. But for now, here's a small puzzle to hold as you drift. Of the two, which one do you suppose does most of the moving? The big one or the little one? Guess, if you like, as you lie there. And know that the answer, when it comes, is one more piece of how considerate this whole arrangement turns out to be. And I'll give you one last thread, the smallest of them all, and in a way the most astonishing. The entire spectacle, this whole grand 4-year dance of two worlds trading orbits around a giant ringed planet, comes down to a difference of about 30 seconds. 30 seconds. That's how much faster the inner moon goes around Saturn than the outer one. Half a minute per lap. Less time than it takes to yawn and settle deeper into your pillow. That tiny difference, that half-minute lead, is the entire engine of the whole thing. We'll unspool that too, slowly, and I think it will surprise you how something so small can move whole worlds. But that's the seed. 30 seconds. Hold it gently. So there they are, all our threads, laid out softly beside us in the dark. Two moons on one path, closing forever and never colliding, and the question of what keeps them safe. One moon that hid for 12 years and got a name meaning afterthought. A faint ring no one placed on purpose. The question of which moon moves and which stays nearly still. And the astonishing smallness of the 30 seconds that drives it all. We'll follow every one of those threads to its end, slowly, unhurried, and each one leads back to the same quiet truth, the truth I most want you to carry down into sleep with you tonight. Which is this: what looks like a collision course is not one. What looks like danger, when you get close enough to see it clearly, is care. These two little worlds, lighter than water, cushioned in dust, circling in the cold silver light 1.5 billion kilometers from the sun, are not in trouble. They have never been in trouble. Every 4 years they come as close as they will ever come. They feel the pull of one another across the dark, and instead of crashing, they trade. Gently, precisely, on a schedule you could mark on a calendar. And then they turn away, unharmed, again and again, and again. For as long as there has been a Saturn to circle, and for as long as there will be. Let that be the thing your mind rests on, not the crash it's braced for, the swap it never saw coming, the quiet handoff that has held for eons and will hold for eons more. Stay with me, and stay soft wherever you are. We're going to walk out to the exact moment of the exchange next, and I'm going to show you, slowly, step by careful step, how two moons on the same track feel each other coming, and how, without ever touching, without any collision at all, they change places in the dark and drift safely apart. But before we go there, just breathe for a moment, in, slowly, and out, slowly. Let the cold, patient distance of Saturn settle over you like a second blanket. There's no hurry out here. There's never any hurry out here. The moons have all the time in the world, and so tonight, do you. So let us go there now. Let us walk out to the moment of the exchange, slowly, the way the moons themselves move, which is not fast, not urgent, not dramatic in the way that word usually means, but with the quiet, unhurried inevitability of water finding its level or a river working its way through stone. There is no crash to brace for. There is only the approach, and then the handoff, and then the long retreat into the dark. And if you let me walk you through it, step by careful step, I believe that by the time we reach the far end of the explanation, something in you will loosen. Some knot your body carries into the night, some held breath that has been waiting for the wrong thing to happen, will find it has no disaster to guard against. And it will let go. Start, then, with an orbit. An orbit is not a fixed rail, it is not a groove cut into the dark. It is something more like a falling, a continuous, unceasing fall toward a body that keeps curving away beneath you as you fall, so that you never actually arrive, and you never stop falling, and the two motions together, the falling and the curving, conspire into a circle, or near enough to one. Saturn is massive. It is nearly 100 times the mass of Earth, and it exerts an enormous gravitational claim on everything near it. Janus and Epimetheus are each falling toward Saturn steadily, every second of every hour of every day. They just keep missing it. They have been missing it for a very long time. And in the missing, they travel. Now here is the thing about orbits that matters most for what we are about to describe, the thing that makes the Janus and Epimetheus story not just strange, but deeply, structurally beautiful. Closer orbits are faster. This is not immediately obvious. It runs against a certain intuition that says something far away, and moving in a huge circle must be going fast, while something close and moving in a small circle is more leisurely. But the mathematics of gravity reverses this. The closer you are to Saturn, the harder it pulls you, and the harder it pulls you, the faster you have to move to maintain your falling curve, your orbit. So if you drew a ring around Saturn and stood on it close in, you would be moving quickly. Step outward to a slightly bigger ring, and your pace slows. The rules are clean, the rules are consistent, the rules are always the same. Janus and Epimetheus orbit at about the same distance from Saturn, about 151,450 kilometers from the planet's center, and I want you to feel how far that is, not because it is important to hold the number, but because distance, out here, is the texture of the quiet. 151,450 kilometers is roughly 40 times the distance from New York to Los Angeles. It is a span so large that if you laid the entire diameter of the Earth end to end, you could do it nearly 12 times before reaching that circle in the dark. And yet, on the scale of the solar system, on the scale of the distance between Saturn and the Sun, about 4 billion kilometers, this ring where Janus and Epimetheus travel is something almost intimate. They are close neighbors to a vast world. They share this orbit, but not quite identically. Here is the detail so small it seems impossible that it could matter, and yet it is the engine of everything we are about to describe. The two moons do not orbit at exactly 151,450 kilometers. Their two orbital paths have slightly different radii. The difference is about 50 kilometers. If you picture the orbit of one moon as a circle drawn faintly in the dark, and the orbit of the other as a second circle drawn just outside it, the gap between those two circles, the physical distance between the two rings, is about 50 kilometers. Janus, which is the larger, more massive of the two, runs about 25 kilometers inside the mean, and Epimetheus runs about 25 kilometers outside it, and the total separation between their paths is roughly the width of a small city, a distance you could drive in half an hour on a clear highway. Out at Saturn, in the cold, in the dark, this is almost nothing. The radius of either moon is greater than the gap between their tracks. They move on paths that, if you could see them together, would look almost indistinguishable, concentric rings so close they might appear to be one. And here is where it would be natural to feel the first pull of alarm. Because if their paths are that close, and if gravity acts between them, and if they are both falling around Saturn at nearly the same altitude and nearly the same speed, then surely they are on a course toward each other. Surely, over time, they will close the remaining distance and meet. And the answer is yes. They are gaining on each other. The inner of the two paths is faster, by a very small margin. The moon on the inner track completes one full orbit around Saturn in very slightly less time than the moon on the outer track. The inner moon circles Saturn in roughly 16 hours and 40 minutes, a full orbital period, shorter than a night's sleep. The outer moon takes a tiny bit longer, and when I say tiny, I want to be precise, because this is the moment in the story when the smallness of the cause and the immensity of the effect become most striking. The difference in their orbital periods is about 30 seconds. 30 seconds. One moon circles Saturn in 16 hours and 40 minutes. The other circles Saturn in 16 hours and 40 minutes and 30 seconds. That is the entire gap. Half a minute out of every 1,000 minutes, a difference you would barely notice on a watch. And yet that half-minute gap, accumulated over days, over weeks, over months, means that the inner moon is pulling slowly ahead. Going around its slightly smaller circle slightly faster, it gains a little ground on every lap, creeping ahead of the outer moon the way a car in the inside lane pulls gradually past a car in the outside lane on a long, gentle curve. Not fast, not dramatically, just steadily, and over about 4 years, 4 full years of lapping in this gentle, inexorable way. The inner moon has gained enough ground that the two are beginning to converge, beginning to draw close, beginning to close the gap across the 50 kilometers of space that separates their paths. This is the moment the story asks you to watch, because it is also the moment at which the story diverges from every instinct you might bring to it. The two moons are closing in on the same point in their shared orbit. The inner one is faster, and it is gaining, and the day is coming when they will be nearest to one another, when the gap between their paths is the smallest, and their angular separation in their orbits is also shrinking. It looks, from the outside, like a meeting. It looks like something that ends with contact. But here is the thing. Gravity does not wait. Gravity begins long before contact. Long before two bodies are touching, they are already talking, already exerting a pull on one another that bends the conversation of their motion. And as these two small moons, Janus, about 179 kilometers across, and Epimetheus, about 116 kilometers across, both of them loosely piled rubble drifting in the cold. As they draw within range of one another across their gap, gravity reaches out between them and begins the exchange that will change everything about their paths. The inner moon, the one travelling faster, approaches from behind. It is closing in on the moon that runs ahead of it on the outer track, and as it comes into gravitational range, something shifts. The outer moon exerts a small tug on the approaching inner moon, a forward pull, a gentle acceleration, and in that moment, the inner moon gains a tiny increment of energy. Orbital energy. The kind of energy that, in the mathematics of orbital mechanics, translates directly and precisely into altitude. More energy means a higher orbit. A higher orbit means a slower speed. So the inner moon, tugged forward by this gravitational handshake, finds itself climbing. Its path moves outward, it rises, and as it rises it slows, and as it slows, the relative advantage it had, the tiny edge of being on the faster, inner track, begins to erode. It is no longer the faster moon. It is becoming the slower one. At the same time, the outer moon is also being tugged, but in the opposite direction. The approaching inner moon is pulling on it from behind, and that backward pull, that small theft of orbital energy, means the outer moon is losing altitude. Its path shrinks inward, it descends toward Saturn, and as it descends, it speeds up. The inner track is faster, and the descending moon is now on its way there, accelerating, growing quicker with every second. They are trading. They have not touched. They have not come anywhere near touching. They are still roughly 15,000 kilometers apart at their closest, which is less than the distance from the Earth to its own moon, but vastly more than the 50-kilometer gap between their orbital tracks might have suggested. 15,000 kilometers of space separating two small worlds of ice and rock, a distance so large that if you could drive it, you would be in the car for weeks. And in that distance, all of this is happening. The energy is flowing. The altitudes are swapping. The speeds are reversing. The moon that was inner is becoming outer. The moon that was outer is becoming inner. They are changing places. And then they begin to separate. The one that has risen to the outer track, the one that used to be the inner, faster moon, is now slower. It is falling behind. And the one that has descended to the inner track, the one that used to be the outer, slower moon, is now faster. It is pulling ahead. And so the gap between them, which had been shrinking over 4 years of gradual approach, now begins to widen again. They are moving apart. One is leaving, one is falling back. The near miss, if it was ever truly a near miss, is already over. They are already on their way to the far reaches of their shared orbit, a full lap apart, sailing away from one another on exchanged paths, receding into the cold. And in about 4 more years, the whole thing will begin again. The new inner moon, which is the old outer moon, which is whichever one is on the lower, faster track now, will slowly gain on the one ahead of it, closing in over the course of 4 years, and when they come within gravitational range, they will swap again. The one that was inner becomes outer. The outer becomes inner. They part. The cycle continues. This is the horseshoe orbit. The name comes from the shape of the path each moon traces in a particular way of watching, a frame of reference that moves along with the orbital dance rather than watching from a fixed position outside it. If you could hover above the Saturn system and let yourself drift at exactly the average orbital speed of the 2 moons, not standing still, not watching from far away, but moving with them, matching their average pace, then you would see each moon trace a horseshoe shape, a wide U, a graceful arc that approaches from one side, curves and retreats along the same path in the opposite direction. The moon never goes all the way around and comes back from the other direction. It curves and returns. It comes close and retreats. The closed horseshoe shape of that path is the visual fingerprint of exactly the kind of exchange we have just described. It matters to say what the horseshoe orbit is not, because the contrast reveals what makes Janus and Epimetheus so singular. There is another kind of co-orbital arrangement in the solar system, and it is far more common. You may have heard of the Trojan asteroids of Jupiter, swarms of small bodies that share Jupiter's orbit around the Sun, but not equally. They cluster near two special points in Jupiter's orbit, roughly 60 degrees ahead of Jupiter and 60 degrees behind, where the gravitational influence of Jupiter and the Sun combine to create pockets of stability. These are called Lagrange points, specifically the L4 and L5 points, and bodies that settle near them trace small, looping paths called tadpole orbits, because in the rotating reference frame they trace an oval shape, compact and contained, like the curve of a tadpole swimming in place. They circle their Lagrange point without ever departing far from it, and they certainly never approach Jupiter closely. They are anchored. Saturn has its own version of this. The moon Tethys has two small companions, Telesto and Calypso, that ride its orbit, 60 degrees ahead and 60 degrees behind. The moon Dione has companions of its own, Helene and Polydeuces. All of these are tadpole bodies, settled into stable Lagrange positions, gently looping in their small ovals, anchored to their larger neighbour across a fixed angular gap. They do not trade places, they do not approach their partner moon and then retreat. They simply follow, quietly, at a distance, in their gravitational niche. Janus and Epimetheus do something entirely different. And the reason they do something different is rooted in their masses. When one body is very much larger than another in a co-orbital system, the large body dominates. The small one settles into a Lagrange point and stays there, anchored by the gravitational well of the larger body, unable to push back with enough force to disturb the arrangement. The dance is asymmetric. One leads, one follows. But when two co-orbital bodies are comparable in mass, not necessarily equal, but in the same order of magnitude, neither one can fully dominate the other. Their mutual gravitational conversation is more balanced. Janus is about 3.5 to 4 times more massive than Epimetheus. That is a real difference, and we will come to what it means for the shape of the swap in a few moments. But it is not 100-fold difference, not 1,000-fold. They are, in the broad register of planetary science, in the same category of things. And that near parity is precisely what turns the tadpole orbit into a horseshoe orbit. Neither moon is heavy enough to pin the other into a Lagrange point. Neither can hold the other at a fixed angular distance. So instead of circling a stable point, each traces the long horseshoe, each approaches and retreats, and each takes a turn on each side of the exchange. They are, as far as astronomers have found, the only pair of natural moons in the solar system doing this. Not the only pair doing something interesting. Not the only pair that shares a rough orbital neighbourhood. The only pair that regularly, predictably, reciprocally trades places in a horseshoe exchange. Two worlds circling the same enormous planet on paths separated by less than their own diameter, and instead of crashing, instead of one sweeping the other aside, instead of chaos, they have evolved, or settled into, or been arranged by the deep mathematics of their situation. This particular solution. This one choreography, the swap, the graceful retreat, the long separation before the next approach. And I want to stay here for a moment in the strangeness of that exclusivity, because I think it matters to the particular kind of reassurance this story offers. We live in a universe that has had billions of years to arrange its contents. Gravity has been at work for a very long time, pulling things together, sending things apart, selecting for what is stable, and wearing away at what is not. Most configurations that looked like they might lead to collisions did lead to collisions in the early solar system when the planets were forming and the debris field was thick. Moons crashed into planets. Asteroids crashed into one another and broke into rubble. The early solar system was violent in a way the present one mostly is not, and the things that survived that violence are the things that found stable configurations, arrangements that could persist, paths that could be maintained. And of all the surviving moons, of all the bodies that found stable arrangements and settled into them, of all the geometries that gravity permits in a moon system, only one pair landed on this particular geometry. Only Janus and Epimetheus in the entire catalogued solar system resolved their situation with this specific answer, which means the horseshoe exchange is not easy. It is not the default. It requires a particular set of circumstances, comparable masses, a shared orbital radius, the right relationship between gravitational reach and orbital speed that apparently occurs only once in the planetary system we live in. And yet it is stable. And yet it works. And yet it has been working without interruption for as long as these two moons have existed, which is almost certainly long enough to stretch back toward the early formation of Saturn's moon system. Perhaps 4 billion years ago, perhaps more. The stability is important. The stability is, I think, the heart of the reassurance. Because one of the things the mind does at night, the worried mind, the sleepless mind, is treat unusual things as fragile things. It treats the unlikely as the precarious. If something seems improbable, the mind wants to know when it will fail. When will the luck run out? When will the thing that should not be working finally stop working? And this is a reasonable instinct in many situations, but it is exactly the wrong instinct to bring to Janus and Epimetheus. The horseshoe exchange is not a lucky accident. It is not a configuration they happen to fall into and will eventually fall out of. It is a self-correcting equilibrium, a dynamical, stable state. The physics that governs the swap is the same physics that keeps it repeating, not despite the exchange, but because of it. Every time the two moons approach close enough to exchange orbital energy, they do exactly what is needed to prevent them from colliding, and then they separate. The approach causes the exchange causes the separation. The separation allows the slow build-up to the next approach. And the next approach causes the next exchange. The mechanism is its own maintenance. Think of it like a thermostat, but written in orbital mechanics rather than in circuitry. A thermostat does not randomly decide to cool a room. It responds to the temperature rising above a threshold by activating the cooling, and the cooling brings the temperature back below the threshold, and the threshold falling deactivates the cooling, and the room warms again toward the threshold. The system self-regulates. It does not need an outside hand to keep it in balance. It carries the balance inside its own logic. The horseshoe exchange works the same way. When the two moons are far apart, the trailing one gains on the leading one, very slowly, over years. This is the room warming. When they come close enough, the gravitational interaction reverses the gaining and sets them apart. This is the cooling. They retreat. They gain again. They approach. They exchange. Every step in the sequence triggers the next step, and the sequence keeps turning reliably without anyone to wind it, without any force arriving from outside to set it right. This is not luck. This is architecture. And architecture, unlike luck, does not expire. So when you hear that Janus and Epimetheus have been trading orbits for billions of years and have never collided, I want you to resist the temptation to hear it as a statement about fortune narrowly escaped again and again. It is not a story of a close call repeating. It is a story of a system that cannot close the call, that has been designed by the patient indifferent geometry of gravity so that the very approach that would seem to promise a collision is the same approach that makes the collision impossible. The moons close in, and in closing in, they do the only thing they can do. They swap. The crash was never available. It was not on offer. It was ruled out from the beginning by the mathematics of the situation. And now I want to show you the 30 seconds. Because all of this, the 4-year approach, the gradual closing of the gap, the vast, slow accumulation of gravitational tension that eventually tips into the swap, all of it flows from a difference of 30 seconds per orbit. 30 seconds is the difference in how long each moon takes to circle Saturn when it is on the inner track versus the outer track. When one moon is sitting on the inner path, it completes its lap in roughly 16 hours, 40 minutes, and 0 seconds. When that same moon is on the outer path, after the swap, it takes 16 hours, 40 minutes, and 30 seconds, half a minute longer. And from that half minute, everything follows. Half a minute per orbit means, over 100 orbits, the inner moon has gained 50 minutes. Over 1,000 orbits, it has gained more than 8 hours. Saturn's moons travel fast, 16 hours and 40 minutes per lap, so 1,000 orbits takes about 694 days, roughly 2 years. In 2 years, the inner moon gains 8 hours on the outer one in terms of orbital progress. In 4 years, it has gained 16 hours, which is nearly a full orbital period. And gaining a full orbital period of ground is, in the geometry of circular orbits, exactly the kind of approach that puts two objects on the same track within striking distance of one another. The slow accumulation of that half minute, orbit by orbit, is what brings them together. That is the gravity of the situation, quite literally. 30 seconds is a thing you can feel. You can breathe slowly for 30 seconds right now and feel the passage of it, the quiet length of it. You breathe in, you breathe out, you breathe in again, and somewhere in the middle of that second breath, 30 seconds have elapsed. It is not long. In the context of 16 hours and 40 minutes, it is almost nothing. It is 0.05% of the total journey. Less than one part in 2,000, and yet it is everything. Every 4 years, that 0.05% compounds into a meeting. Every 4 years, two worlds that have been drifting steadily apart find themselves once again drawing near. And every 4 years, the gravitational exchange that resets the clock begins again. The 30 seconds is taken away. The 30 seconds is given back. The difference rebuilds, the approach rebuilds with it, and 4 years later, once more, the swap. There is something almost meditative in this rhythm. Not fast, not urgent, not the sharp, bright urgency of a crisis, but the long, slow rhythm of something that takes years to set itself up, and then completes itself in a gravitational moment, and then takes years to set itself up again. A clock that ticks once every 4 years. A tide that rises and falls on a scale measured in presidential terms and planetary seasons. You could mark a calendar. You could note the year and leave a note for yourself, and come back 4 years later and look up at Saturn if you had the equipment to find it. And know that out there, in the cold, in the dark, the swap has happened again. As it happened in January 2006, as it happened in January 2010, as it will keep happening, quietly, on its long, patient cycle, whether or not anyone on Earth is watching. And I find myself wanting to say something about what that kind of reliability feels like. Because reliability, true reliability, the kind that has been tested not across a human lifetime or a historical record, but across geological time, across the kind of span in which mountains form and erode, and the continents move, and the species rise and fall, that kind of reliability has a quality to it that is different from anything we usually call reliable. We call a friend reliable when they have shown up again and again across the years we have known them. We call a structure reliable when it has stood through storms and decades. But the reliability of Janus and Epimetheus is operating on a scale that makes these things seem like minutes. 4 billion years, approximately 4 billion repetitions of the approach, the exchange, the retreat, and each one clean. Each one completing itself without collision, without chaos, without failure. Not because someone was watching, not because a force arrived to prevent the crash, but because the crash was never in the mathematics. The thing your mind is bracing for tonight, whatever it is not this. Whatever your mind has assembled in the dark and labelled as the oncoming thing. The thing that must eventually go wrong, it is not the horseshoe orbit. It is not the self-correcting equilibrium running on 4 billion year tested geometry. It is something else. Something human, something contingent, something subject to 1,000 variables and outcomes that cannot all be predicted. I know that. I am not trying to tell you that your worries are not real, or that the things you fear cannot happen. I am only trying to show you, in the most concrete terms I have available to me, what it looks like when a system that could go wrong simply doesn't. Not because of luck, because of structure. Because the very mechanism of the apparent danger is also the mechanism of the safety. Because the approach and the exchange and the retreat are one thing, not three, not a threat followed by a narrow escape, but a single, indivisible motion that has been called an exchange of orbits and could just as accurately be called an exchange of futures. The moon that comes in is already leaving. The departure is built into the arrival. In about 30 seconds per orbit, in about 4 years per swap. In about 15,000 kilometers of closest approach out at Saturn, in the cold, with no one watching but the stars and the faint dust ring they paint themselves, which glows so softly in the sunlight that it took a spacecraft nearly 20 years to find it. But that ring is the next part of the story, and we are not there yet. Right now, I want you only to hold the mechanism, the inner moon, the outer moon, the 30-second difference, the 4-year approach, the gravitational handshake, the exchange of altitude and speed, the retreat into the dark, the long wait before the next approach, and the knowledge, which is now your knowledge, that the system cannot fail the way it might appear about to fail. Because the apparent failure is the mechanism of the safety. The near miss is the guarantee. The approach is the departure. Let that sit in your body for a moment. Not as an idea to analyze, but as a physical sensation. The loosening of something that has been held. The easing of a grip you did not know you were keeping. Let the orbital mechanics of 2 small frozen worlds circling a ringed planet 1.5 billion kilometers away do a small piece of work for you tonight. Let them show you, at the scale of the cosmos, what a reliable system looks like. What it feels like for something to have been working perfectly, without failure, for longer than the planet you are lying on has had oceans. It has never failed. Not once in 4 billion years has the approach ended in collision. Not because they were lucky, because they could not collide, because the physics would not permit it, because the very forces that bring them close are the same forces that ease them safely apart. And they will do it again, and again after that, and the stars will not shift, and the cold at Saturn will not warm, and the 30-second difference in their orbital periods will persist, and every 4 years the clock will tick, and the exchange will happen, and the moons will retreat, and the silence at the outer edge of Saturn's ring system will settle back over everything, undisturbed, as though nothing remarkable occurred at all. And yet something remarkable did occur. Something small and precise and deeply orderly, and it is worth staying with for a moment longer, because the details of how the exchange actually distributes itself between the two moons reveal a kind of fairness built into the physics, a quiet asymmetry that, once you see it, makes the whole system feel less like a celestial accident and more like something that was, at some level, designed to work out. Think about what is happening at the moment of the swap. Two moons, travelling along the same ring-shaped road around Saturn, approaching from different starting positions, drawing closer over the span of 4 years until they have closed to within roughly 15,000 kilometres of each other, and then gravity reaches between them, and something passes from one to the other, orbital energy, the invisible currency of motion in space. The inner moon, the faster one, the one that has been running to catch up all this time, gives some of that energy away to its companion. The outer moon receives it, and they each shift into the other's lane. The inner moon rises outward. The outer moon drops inward, but they do not shift equally. This is the part almost nobody tells you, and it is one of the more beautiful details in the whole story. When two objects exchange momentum, each one changes by an amount that is inversely proportional to its mass. The heavier one barely moves, the lighter one travels far. If you have ever pushed someone much larger than you on a skating rink, you understand the principle. They glide forward a little, you shoot backward a great deal. You absorbed most of the change. They barely noticed. Janus and Epimetheus are not equal in size. Janus is the larger of the two, a lumpy, cratered, irregularly shaped body roughly 179 kilometers across at its widest, with a mass of nearly 2 billion kilograms. Epimetheus is considerably smaller, closer to 116 kilometers wide, and about 3.5 to 4 times less massive than its partner. They are both small by any planetary standard, both rubble piles of ice and rock that would fit comfortably inside a medium-sized American state, but between them the size difference is real and consequential. And so when the exchange happens, momentum must be conserved, the books must balance. The total kinetic energy of the system does not change, it simply redistributes. And because Janus is so much heavier, it shifts only slightly. At each swap, Janus moves its orbital path by about 20 kilometers. 20 kilometers. Which sounds like a lot if you are thinking about roads and cities. But in the context of two moons circling Saturn at a mean distance of 150 kilometers from the planet's center, 20 kilometers is a rounding error. It is the kind of distance that at Saturn's scale you might not even notice if you were watching from far away. Janus barely flinches. It takes the energy exchange with something close to composure, shifts a few city blocks worth of orbital altitude, and continues. Epimetheus, on the other hand, is flung. Not violently, not catastrophically, but with a decisiveness that is striking when you consider the gentleness of the whole encounter. Because Epimetheus must absorb all the momentum that Janus surrenders. And Epimetheus is so much lighter that absorbing the same quantity of momentum means moving 4 times as far. At each swap, Epimetheus crosses roughly 80 kilometers of orbital space. 80 kilometers. Which is the same as saying that the smaller moon travels a distance roughly equal to its own diameter just to make room in the orbital accounting for its heavier partner. Janus moves 20 kilometers and lets the universe handle the rest. Epimetheus moves 80 kilometers and does, proportionally, most of the work. There is something in that image that feels almost human. The smaller one making the larger adjustments. The lighter partner doing the heavier lifting of the actual transit. Not out of obligation, not out of choice, but simply because that is what the physics requires, because mass and momentum do not negotiate, and the smaller body has less inertia to resist the change. The system does not ask whether this is fair, it simply executes, faithfully, according to the only rules that apply. And this is the part that turns the asymmetry into something approaching balance, it reverses. Not immediately, not at the next swap, but over the full cycle of the exchange, over the complete rhythm of what astronomers call the libration, each moon takes an equal turn carrying the load. The libration cycle takes roughly 8 years, 2 4-year swaps to complete. For the first half of that cycle, one moon runs the inner track, the faster lane, the one where it is accumulating speed and closing the gap on its companion ahead. For the second half, after the swap has reversed it to the outer track, it runs more slowly, and it is the other moon that is now on the inside, catching up. Each moon spends approximately 4 years as the inner, faster body. Each moon spends approximately 4 years as the outer, slower one. The roles alternate with a fairness that no human institution has ever quite managed. There is no permanent hierarchy. There is no moon that always leads, and no moon that always follows. Every 4 years the positions reverse, and the one that was behind becomes the one ahead, and the one that was ahead drops back. And over the long arc of the cycle, the 2 moons share the burden and the position in equal measure. One way to picture it, imagine 2 runners on a circular track, so close to each other that their footfalls are only separated by a handful of steps. One is slightly faster. Over time, the faster one closes in on the one ahead. When they are nearly side by side, something passes between them. Not a collision, not even a touch, but a transaction, a transfer of pace, and the faster one slows down, and the one who was being caught speeds up, and they are no longer side by side, but already separating again, roles switched, the former leader now beginning its long patient journey of catching up from behind. And they do this every 4 years. And have done it for a very long time. That rhythm, the patient accumulation, the gentle exchange, the unhurried retreat, is not what most people picture when they think about 2 moons sharing an orbit. The word sharing implies a kind of static equality, 2 objects somehow nestled into the same space at the same time. But this is nothing like that. This is dynamic. This is a negotiation that takes 4 years to develop and executes in what is, at the timescale of the solar system, a single long breath. The orbit is not shared the way 2 people share a table, sitting together quietly. It is shared the way 2 people share a single chair, taking turns, each yielding at the right moment, each rising when the other approaches. Neither one insisting on remaining in place when the physics politely asks them to move. And the physics is always polite. And neither moon ever fails to yield. Now, there is a question that was not asked for a very long time, partly because the answer was considered obvious, and the obvious answer happened to be wrong. The question is, how many moons are circling Saturn at this particular orbital distance, on this particular ring road, at approximately 1,000 kilometers from the planet's center? For a long time, the answer was assumed to be 1. The story of how that assumption was overturned is one of the more quietly delightful episodes in the history of planetary science. And it begins in the winter of 1966, when a French astronomer named Audouin Dollfus was working at the Pic du Midi Observatory in the French Pyrenees, turning his instruments towards Saturn during one of the planet's ring plane crossings, those rare periods when Saturn's rings appear nearly edge-on from Earth, thinning to a line and becoming almost transparent, which clears the visual field around the planet and makes fainter objects near it easier to detect. On the 18th of December 1966, Dollfus observed something small and faint at the edge of Saturn's ring system that did not appear to be one of the planet's already known moons. He tracked it through several nights, confirmed that it was orbiting Saturn, and reported the discovery. The new moon was provisionally designated S1966S1, and it was eventually confirmed and named Janus, the Roman god of doorways and thresholds, of beginnings and endings, of every transition from one state to another. Janus, famously, has 2 faces. One looks toward the past, one looks toward the future. He is the god you invoke at a threshold, at the moment between what was and what will be, standing precisely at the hinge. The name, as we will return to, fits almost eerily well. But in the months after Dollfus's announcement, something odd kept happening. Other observers were looking in the same region, tracking what everyone assumed was the same newly discovered moon, and their measurements were not lining up. The positions did not quite agree. A moon, travelling at a predictable orbital speed, should be roughly where you expect it to be when you point a telescope at the right patch of sky. This one was not reliably doing that. There were extra sightings from angles that did not make sense if there was only a single body tracing a single path. An astronomer named Richard Walker recorded observations in early 1966. Before Dollfus's December announcement, that recorded an object at the same orbital location, but the details of his observations, compared with Dollfus's, raised quiet questions that nobody was quite ready to answer. The problem was set aside. Not ignored, exactly. It sat in the literature, in the footnotes of papers, and the careful caveats of researchers who noted that the orbital parameters of the new Janus were not entirely internally consistent. But it sat there, unresolved, because the simpler explanation was that there were measurement errors, or atmospheric distortions, or the ordinary difficulties of tracking a dim, tiny object at the edge of Saturn's distant ring system, with the ground-based instruments of the 1960s and early 1970s. The puzzle sat there for 12 years. 12 years is a long time to have the wrong answer about something, but in this case, the wrong answer was so intuitive that it took considerable ingenuity to even frame the right question. There was one moon. Everyone had seen it. The question was only whether the measurements were reliable, not whether there was, impossibly, a second moon hiding in the same track. And then, in 1978, 2 American astronomers named Stephen M. Larson and John W. Fountain sat down with the accumulated observations, all the sightings, all the position measurements, all the conflicting data points that a decade of careful researchers had been quietly puzzled by. And they worked through what would have to be true for all of those observations to be correct simultaneously. Not mostly correct or approximately consistent, but actually precisely correct, every data point included. The only solution that fit was 2 moons. Not one moon on a slightly irregular path. Not one moon subject to unusual perturbations. 2 separate bodies, both orbiting Saturn at essentially the same distance, both small enough that any individual observation might reasonably be attributed to a single object seen at slightly different positions in its orbit. 2 moons, circling so close to each other's track that for 12 years the astronomical community had been watching first one, and then the other, sometimes one, sometimes the other, sometimes catching both in the same observation without realizing it, and adding all of this up into the single tidy figure of 1. Larson and Fountain published their resolution in 1978. There were 2 co-orbital moons. The one Dolphus had first spotted was Janus. The second, the one that had been hiding in plain sight for more than a decade, was given a name of its own, Epimetheus. Epimetheus, the name, is from Greek mythology, and it carries a particular weight in this context. Epimetheus is the brother of Prometheus, where Prometheus means forethought, the one who plans ahead, who sees what is coming, who steals fire for humanity because he has already reasoned through the consequences. Epimetheus means the opposite. Epimetheus means afterthought. Hindsight, the one who acts and only afterward understands what he has done. In the old myths, Epimetheus is the one who, when Pandora arrived carrying her famous box, accepted her without stopping to think about what might be inside. He learned his lesson only after the fact. A moon named Afterthought. A moon that was, literally, the afterthought of 12 years of observation. The one that astronomers looked at and nearly saw and nearly understood and only afterward realized was there. A moon hiding at the same orbital distance as a moon everyone was already watching, and going unnoticed for over a decade, and receiving in the end the name of the one who learns only in retrospect. The naming is almost too good. It is the kind of correspondence that, in a novel, you would mark as too neat, too convenient, the sort of thing a writer does when they want to make a thematic point and cannot resist the elegance of the symbol. But this is not a novel. This is what happened. Epimetheus, the moon that was an afterthought in the human record of Saturn's family, was given the name of the figure whose defining quality was that he always understood things only after the moment had passed. And Janus, the god of doorways, the god of the threshold, the god who stands at every transition from one state to another and presides over the passage. Depicted always with 2 faces, one looking backward, one looking forward, one oriented toward where he has been and one toward where he is going. The Roman calendar began with his month, January. Every new year, every new beginning, falls under the sign of the 2-faced god who looks in both directions at once. 2 moons that are forever changing places, forever oriented toward where the other has been, forever handing back and forth the positions of inner and outer, leader and follower, the one ahead and the one behind. 2 faces, 2 directions, 1 threshold, repeated every 4 years. A doorway made of orbital mechanics. It is worth sitting with that for a moment. The ancients who gave us these names were not thinking about co-orbital resonance. They were thinking about the mythological figures they knew, and someone at some point in the naming process thought that Janus, the 2-faced, threshold-dwelling, beginning and ending god, was the right name for a moon near Saturn's ring edge, and that, Epimetheus. The afterthought, the brother of forethought, was the right name for the second overlooked body in that same region. And they were more right than they knew. The names fit not only as labels but as descriptions. Janus is the moon that governs a threshold, the place where inner becomes outer and outer becomes inner, the hinge of the swap. And Epimetheus is the one that was only seen clearly in retrospect, the one that required 12 years of accumulated observations and a pair of clever astronomers to look backward over the data and say, "We missed one. We missed one." It is an interesting thing to have been watching the right place and seeing the wrong number of things there, to have accumulated years of careful observations that were each, individually, perfectly accurate, and yet to have been summing them into the wrong picture. Each sighting of Epimetheus was a real sighting. Each measurement was genuine. The data was not wrong. The interpretation was wrong, because the interpretation was constrained by the assumption that there could only be one thing there, and so every genuine glimpse of the second moon was quietly folded into the account of the first, absorbed into the story of Janus, misidentified as an irregular position measurement rather than recognized as a separate body with its own irregular position. This is not a failure of science. It is, if anything, an illustration of how science actually works at its careful, painstaking best. The observations piled up. The inconsistencies were noted. Someone eventually sat down with all of it and asked what would have to be true for all of the inconsistencies to dissolve, and the answer that came back was not measurement error, but a second moon. And the second moon was looked for, and the second moon was found. The process took 12 years, but it got there. It always gets there. And then, in November of 1980, a spacecraft called Voyager 1 arrived in the Saturn system and ended the ambiguity entirely. Voyager 1 was launched in September of 1977, part of a two-spacecraft mission that would become the most ambitious planetary tour ever attempted. Both Voyager 1 and its sister craft, Voyager 2, were launched to take advantage of a rare alignment of the outer planets, a geometric arrangement that occurs only about once every 175 years, in which Jupiter, Saturn, Uranus and Neptune are positioned such that a single spacecraft, using each planet's gravity as a slingshot, can visit all four in sequence. The Voyagers launched in 1977 because the window was open. The next window would not open until the 22nd century. Missing it would have meant waiting for an alignment that nobody then alive would see. Voyager 1 reached Saturn in November of 1980. It swept through the system at high speed, its cameras and instruments trained on the planet, the rings, and the moons, capturing images and data that transformed our understanding of the entire outer solar system. And among the targets of its cameras were the two small bodies in the co-orbital track near the ring edge, the two objects that Larson and Fountain had predicted must be there, that the ground-based record had only circumstantially supported. Voyager 1 imaged both of them. Separately, distinctly, two moons, clearly two, clearly different in shape and size, each captured in its own right. Each photographed as its own irregular, cratered, lumpy world. The 12-year uncertainty was resolved in a set of images transmitted across hundreds of millions of kilometers of space, and what came back was unambiguous. Two moons in one orbit, exactly as the mathematics had said there must be. Voyager 2 followed in August of 1981, adding to the picture. And the moons that had been a puzzle, that had been a single confusing observation, then a tentative hypothesis, then a mathematical resolution, then a Voyager confirmation, settled into the catalogue of Saturn's family as Saturn X and Saturn C, Janus and Epimetheus, the two co-orbital bodies. The pair that trades places every 4 years and has never once collided. What Voyager could not do, in its brief high-speed transit, was watch the swap in real time. The spacecraft was passing through, not lingering. It could image the moons, measure their positions, estimate their sizes and shapes and orbital parameters. It could not sit in orbit for years and watch the exchange happen at the pace it actually happens, the slow 4-year approach, the gravitational handshake, the retreat and the reversal. For that, the solar system would have to wait for a spacecraft that was not passing through, but settling in. That spacecraft would come. But that part of the story belongs to a slightly later chapter of this long, quiet night. For now, rest with what has been given. The two moons are real, their orbital partnership is real, their names are real, and the names fit in a way that feels like more than coincidence, though it is almost certainly coincidence, and perhaps that is even better. Because it means the universe arrived at this particular elegance without trying, as a side effect of the things that actually happened, and the things that were named, and the small accidents of mythology and memory that connect an ancient Roman god of transitions to a pair of icy rubble piles circling a ringed giant 1.5 billion kilometers from the sun. Janus, who looks in two directions at once, at what was and at what will be, at the track just abandoned and the track just entered. The god of the threshold, named for a moon that has been crossing thresholds every 4 years for as long as the inner solar system has had oceans. Epimetheus, who understood things only in retrospect, who learned the lesson only after the moment had passed. Named for the moon that was understood only in retrospect, only after 12 years of observations had piled up, and someone looked back over all of it and said, quietly and carefully, there are 2 of them. There have always been 2. We simply did not know how to see it until we had enough data to look back and read the truth that was already there. The naming, whether by accident or by some half-conscious reaching for the right myth, is almost exactly right. And there is one more layer to the naming, one more thread in the mythology that winds through this particular corner of the Saturn system. Epimetheus, in the Greek stories, had a brother. His name was Prometheus, meaning forethought, the planner, the one who sees ahead. Prometheus is the Titan who stole fire from the gods and gave it to humanity, who looked at the future and decided to act before the moment arrived, who suffered enormously for the crime of thinking ahead. And Prometheus is also the name of another moon of Saturn. Prometheus is a small irregular body that acts as a shepherd for Saturn's F-ring, a narrow, braided, slightly mysterious ring that runs just beyond the main ring system. Prometheus herds the particles of that ring, nudging them with its gravity, keeping the ring's shape from dispersing. It is, in the vocabulary of celestial mechanics, a shepherd moon. And it orbits Saturn in the same general region as Janus and Epimetheus, though not in their track. Close enough that the mythological correspondence feels almost curated, a small pantheon of Greek and Roman figures arranged at the outer edge of Saturn's rings, as though someone deliberately placed them there to tell a story. Epimetheus and his brother Prometheus, both orbiting the same cold planet. Afterthought and forethought, both present, both small, both icy and cratered and shaped by the same ancient forces. One of them herding a ring, one of them trading orbits with the god of doorways. This is flagged here as mythology, not astronomy. The connection between Prometheus the moon and Prometheus the myth is a naming convention, a human choice, and it carries no physical significance for the behavior of the moons themselves. But names are how minds hold things, and the mythological texture of this part of the Saturn system, the gods and titans arranged in their orbital positions. each one quietly performing the action that their name suggests, is one of the gentler pleasures of looking at the sky with a little history alongside the physics. Forethought and afterthought, both in orbit. The god of thresholds trading places with the afterthought, every 4 years, reliably, peacefully, without drama, out in the cold dark beyond the ring. This is where the story settled for a while after Voyager passed through. 2 moons, confirmed, named, catalogued, understood in broad outline. They shared an orbit, they exchanged positions every 4 years, their masses were unequal, and so their movements during the swap were unequal, and the exchange was stable and self-correcting, and not the result of luck. That much was established in the early 1980s, that much was known. But what Voyager saw was a snapshot. A few days, a few frames, a brief and incomplete portrait of 2 moons in one frozen moment of their long partnership. The detailed texture of what they look like, the specific character of their craters, the subtle shape of their irregular surfaces, the fine structure of their shared orbital environment that would wait for a spacecraft that did not have somewhere else to be. And there was something else waiting to be discovered, something that Voyager's instruments, in their brief transit, did not have the sensitivity or the time to find. Something that the 2 moons had been building without any assistance for a very long time. Something faint and diffuse, and spread in a thin haze along the path they both travel, visible only in the particular angle of Saturn's light, visible only to a spacecraft patient enough to look. A ring. Not one of the great bright rings that Saturn is famous for, not the broad brilliant bands of ice and rock that catch sunlight and scatter it back toward Earth in photographs that have been reproduced on spacecraft mission patches and textbook covers and the walls of schools and science museums for half a century. Not a ring anyone placed there, or designed or expected to find. A ring that Janus and Epimetheus made themselves. Slowly, over billions of years, grain by grain. When you throw a handful of sand at a stone wall, the grains that strike the surface do not simply stop. Some of them bounce, some of them break, and some of them, over a long enough period of time, and with enough collisions behind them, are released from the surface altogether and drift away. Lifted by the tiny kinetic violence of each new impact, floating free into whatever space surrounds them. Janus and Epimetheus have both been moving through a region of space that is not empty. Out here, beyond the edge of Saturn's main ring system, small objects drift in orbit, fragments of ice, specks of rock, pieces of the solar system's early debris field that have survived billions of years of slow attrition. And some of those objects are not passive. Some of them move. Some of them strike. Micrometeoroids, particles so small that the word meteor seems almost too dramatic for them. Tiny fragments, travelling at the enormous velocities that orbital mechanics produce, no bigger than grains of dust, no heavier than a breath, have been hitting the surfaces of both moons for as long as both moons have existed. Each impact is individually trivial. Each one leaves the faintest of marks, excavates the most microscopic of craters, ejects a thin spray of surface material. Ice and powdered rock, loose regolith, the fine debris that coats the exteriors of these rubble-pile worlds, upward and away from the surface. Most of that material falls back. Gravity, even the faint gravity of a small moon like Janus or Epimetheus, is enough to reclaim what was briefly lost. The dust settles, the surface absorbs it. The moon continues on its way, unaware, tidally locked and patient, its long axis pointed toward Saturn as it has always been pointed. But not all of it falls back. Some of it, just a fraction, the fraction with enough velocity to escape the moon's shallow gravitational grip, drifts away. And drifting away from a moon that is orbiting Saturn does not mean drifting away from Saturn. It means entering an orbit of your own, a very similar orbit, a path around Saturn that is almost identical to the path of the moon you just left. You are a grain of dust now, and you orbit roughly where Janus orbits, roughly where Epimetheus orbits, spread out along the path they both travel, diffuse and faint and invisible to any instrument not specifically designed to find you. Over billions of years, both moons have been shedding themselves this way, grain by grain, impact by impact, a slow, continuous, imperceptible exhalation of material that spreads along their shared track, forward and backward along the path, thinning with distance, mixing with the similar dust shed from both bodies, until the whole orbital band contains a faint haze of material that belongs to neither moon exclusively, but to both of them together. This is the Janus Epimetheus ring. It is not a structure you could see if you were standing on one of the moons and looking outward. It is not dramatic. It is not a feature that resolves into individual ice chunks and rocks the way Saturn's main rings do. It is a suggestion of material rather than a solid presence, a diffuse belt of dust tracing the path that Janus and Epimetheus have always shared. Visible only in specific geometries of light, visible only when Saturn's illumination strikes it at a low angle and the dust scatters that light back in a way that instruments can measure. Cassini found it. That is how it was discovered, by a spacecraft orbiting Saturn with the patience and the precision to look for faint things in the right way at the right moment. The year was 2006. Cassini had been in orbit around Saturn for 2 years by then, and its suite of cameras and spectrometers had been doing what they had always been designed to do, looking carefully at a system that no telescope from Earth could fully resolve, building up a picture of Saturn and its family that Voyager had only sketched in passing. And in 2006, looking outward from Saturn in certain configurations, the instruments detected it. A thin, faint ring of dust tracing the path of the 2 co-orbital moons. A ring that the moons had been building, quietly and without intention, across the whole of their long partnership. There is something that stops you when you sit with that fact for a moment. Not because it is the most dramatic feature of this system. Not because the Janus Epimetheus ring competes in any way with the great bright bands of the A and B and C rings, those iconic structures that have defined Saturn's image since the earliest telescopes. It is faint, it is thin. It would not appear in the classic photographs that made Saturn famous, but it is there because Janus and Epimetheus put it there. Without trying, without knowing, as a byproduct of simply existing in this place for as long as they have. 2 irregular lumps of porous ice and rock, circling a gas giant in their quiet shared orbit, have authored a ring with nothing but time and the physics of small collisions. They did not build it. They are building it still right now as the micrometeoroids continue to strike, as the dust continues to escape, as the grains continue to drift forward and backward along the track. The ring is a record, a faint, diffuse, permanent record of how long they have been here and how diligently they have held to this path. And Janus does not only paint its own ring, it shapes another. Farther inward from where Janus and Epimetheus orbit, closer to Saturn, inside the orbit of the main ring system, in the region of those great bright bands, there is a boundary, a specific, sharp edge. Not a gradual fade, Not a region where the ring material simply thins out and disappears as you move outward, but a defined termination. On one side of this boundary, there is ring material. On the other side, there is not. This is the outer edge of Saturn's A ring, the bright, broad outer band of the main ring system, one of the most photographed features in the solar system, a structure that has been reproduced in textbooks and on mission patches and in planetarium projections for decades. That outer edge is sharp because Janus is there. Not directly, Janus orbits outside the main rings, beyond the Roche limit, far above the plane of the densest material. But gravity does not require proximity to act. Janus, orbiting where it orbits, exerts a gravitational influence on the material at the outer edge of the A ring, and the relationship between Janus's orbital period and the orbital period of ring particles at that specific distance creates what is called a resonance. A 7.6 orbital resonance, to be precise, for every 7 orbits that ring particles at the A ring's outer edge complete. Janus completes exactly 6. The timing is not accidental. It is a consequence of the orbital mechanics, a rhythm that locks the relationship between the Moon and the ring material at that specific location, and the repeated periodic gravitational nudges that result from that locked rhythm are what keep the outer edge of the A ring where it is. The particles that would otherwise drift outward are gently, repeatedly reminded by Janus's gravity to stay. And they stay. So this small, irregular moon, this rubble pile lighter than water, this world that is itself in the middle of a continuous, patient orbital dance with its own partner, this moon is also a shepherd. It keeps one of the most prominent boundaries in the solar system clean and precise. Take Janus away, and the outer edge of the A ring would soften, spread, lose its definition over time. Leave Janus where it is, continuing its 4-year exchange with Epimetheus, maintaining its own orbit at 151,450 kilometers from Saturn's center, and the outer edge of the A ring remains. Crisp, defined, photographed by every mission that has passed through this system. It is a small thing for a small moon, but it is an ongoing thing, and it is real. Cassini saw all of this. The spacecraft arrived at Saturn in the summer of 2004. Not a flyby this time, not the brief high-speed transit of Voyager, a capture, a deliberate insertion into orbit around Saturn using a burn of the spacecraft's main engine that lasted just under an hour and a half, slowing Cassini down just enough for Saturn's gravity to take hold. And once it was taken hold of, Cassini stayed. For 13 years it stayed, circling Saturn on orbits that took it close to the rings, close to the moons. Through the magnetosphere and the radiation belts and the thin, particle-scattered space between the ring plane and the atmosphere, building a picture of this system that no observatory and no passing probe could have assembled. It made close approaches to both Janus and Epimetheus over those 13 years. It imaged their surfaces in detail that Voyager could not approach. The craters, the ridges, the smooth areas where regolith has pooled in low places, the irregular limbs where the shapes of these lumpy, aspherical worlds stand out against the black. It confirmed their physical characteristics, the low density, the likely composition, the tidal locking, the specific parameters of their orbital dance. And it measured, carefully and over time, the geometry of their shared path, including the discovery of the dust ring those two moons had been building together for longer than the Earth has existed in its current form. Cassini tracked the swaps too. It was in orbit when Janus and Epimetheus exchanged places in January 2006, and again in January 2010. Those 4-year milestones arriving on schedule, reliably, as they have been arriving for far longer than anyone has been watching. The spacecraft did not need to rush to witness the exchange. It simply had to be there, which it was, orbiting patiently, its instruments measuring the exact orbital positions of both moons and confirming once more that the swap had occurred without incident, that the larger moon had shifted inward by about 20 kilometers, that the smaller moon had moved outward by about 80, that their roles had reversed, that the trailing moon was now the leading moon, that the 4-year countdown had reset, and that both of them were continuing on their way, unharmed, unchanged, as they always had been and always would be. A 4-year metronome, reliable enough to mark on a calendar, reliable enough that you could have predicted the January 2006 exchange before Cassini arrived, that you could predict the next one and the one after that the schedule is as fixed and as knowable as the schedule of an eclipse or a solstice. The universe is full of things that seem chaotic and unpredictable until you understand the mechanism, and then they become as reliable as breathing. The horseshoe exchange of Janus and Epimetheus is one of those things. And when 13 years had passed, when Cassini had documented the rings and the moons and the magnetosphere and the atmosphere of Saturn in more detail than any mission before or since, the spacecraft reached the end of its designed operational life. It was running low on propellant. Without propellant, it could not be steered. A spacecraft that cannot be steered is a spacecraft that will eventually land somewhere without anyone's permission, and in Saturn's system, some of the places it might land were not empty. Saturn has moons that may, in some sense, be alive. Enceladus, with its subsurface ocean and its geysers of water ice, Titan, with its lakes of liquid methane and its thick organic atmosphere. A spacecraft carrying trace amounts of Earth microorganisms, which all spacecraft carry despite every effort to prevent it, crashing into one of those worlds would be a contamination event, a scientific and ethical problem that the mission designers were not willing to risk. So Cassini did what no spacecraft had done before it, and what very few have done since. On September 15, 2017, it flew directly into Saturn. The mission designers called it the grand finale. In its final days, Cassini made a series of orbits that took it between Saturn's atmosphere and its innermost rings, an area no spacecraft had ever entered, a gap of only a few thousand kilometers between the ring plane and the cloud tops. Collecting data from a region that would have been too dangerous to approach at any other point in the mission. And then, on September 15, it angled itself toward the planet, entered the upper atmosphere, and began to burn. The last telemetry arrived on Earth 8 hours and 20 minutes after it was transmitted, because that is how long light takes to travel from Saturn at that distance. The signal ended. The spacecraft was gone, incorporated into the atmosphere of the planet it had spent 13 years documenting, lost in the ammonia clouds and hydrogen layers of a gas giant that is itself mostly empty space. It was not a failure. It was the plan. The grand finale was the final science observation, the final data set. The final gift from a spacecraft that had been extraordinarily productive for longer than many of the engineers who built it had expected it to operate. Cassini did not crash. It completed its mission in the most literal sense, continuing to gather atmospheric data until the moment it ceased to function. And in doing so, it left Enceladus and Titan and the other potentially habitable moons of Saturn exactly as it had found them, untouched by Earth biology, as pristine as the system will allow. Janus and Epimetheus are still there. They did not stop their exchange when Cassini stopped watching. The 4-year clock did not pause. The horseshoe orbit did not require a human witness to continue operating. The orbital mechanics that make the exchange stable and self-correcting are not maintained by observation. They are maintained by physics, which is indifferent to whether anyone is watching or not. The swap happens because the swap is what happens. It has been happening since long before any telescope was pointed at Saturn. It will happen after the last telescope is pointed at Saturn, whenever that is, however far in the future that moment arrives. There is something worth pausing on, in the ordinary texture of an ordinary life, in the sensation of lying in a bed on a planet orbiting a star at 1 astronomical unit, worrying about things that feel enormous and close and urgent. There is something worth pausing on in the fact that this exchange is happening right now. At this moment, one of the 2 moons is on the inner track, circling Saturn just 30 seconds per orbit faster than the other, closing the gap by a small but measurable amount each time it laps the path, beginning the long 4-year approach that will, when the distance has been reduced to roughly 15,000 kilometers, resolve into the gravitational handshake, the orbital swap, the retreat. It is happening whether you are awake or asleep. It has been happening every 4 years, reliably, for longer than the human species has existed. There is something about that rhythm, that specific clockwork quality of a system that requires no maintenance and makes no errors, that is easier to feel in the late hours of a quiet night than at any other time. And this dance, not specifically this dance, but this pattern, this mathematical shape, is not unique to Saturn. Closer to home, far closer than the 1.4 billion kilometers that separate the Earth from Saturn, there is a faint echo of the same geometry. An asteroid, a small irregular rock designated 3753 Cruthen, named after an ancient Celtic people, orbiting the Sun in a path that is not quite identical to Earth's path, but is close enough in the right rotating frame of reference to trace a horseshoe shape. It does not share Earth's orbit the way Janus and Epimetheus share Saturn's orbit. The comparison is not precise, and the geometry is more complex when you account for the additional influence of the Sun and the distance involved. But the mathematical shape of its motion, the broad U-shaped curve it traces relative to Earth, belongs to the same family of orbital configurations. The horseshoe is not an exotic structure invented uniquely for a distant gas giant and its 2 irregular moons. It is a shape that gravity draws in multiple places across the solar system wherever the conditions are right. Wherever 2 objects are close enough and similar enough in their orbital parameters that neither can dominate the other, and so they share and trade and take turns. Cruthen traces that pattern relative to Earth. Janus and Epimetheus trace it relative to each other, at Saturn, in a version that is tighter and more dramatic and better documented, and, in the case of these 2 specific moons, a genuine exchange of orbits that recurs on a clockwork schedule. The mathematics that produces the horseshoe path is the same mathematics in both cases. The universe has a small repertoire of shapes that gravity reliably produces, and this is one of them, available for any 2 objects that find themselves in the right configuration. Distributed across the solar system without ceremony or announcement, waiting to be found. And at the center of all of it, at the center of the exchange and the ring and the shepherding and the discovery and the long catalogued history of this partnership, there is nothing but gravity. No engine, No agreement, no rescue protocol that activates when the two moons draw within 15,000 kilometers of each other. No mechanism that intervenes to prevent a collision, because there was never a collision to prevent. The swap is not an avoidance. It is not a close call that resolves successfully because the universe got lucky one more time. It is the geometry of the situation expressing itself, the way all gravitational systems express their geometries, without drama and without error, along the paths that the initial conditions and the laws of physics have always required. The thing that looks like a collision course is the course. The approach is the setup for the departure. The moment of closest approach, 15,000 kilometers, a world filling the other's sky, enormous and cratered and silent, neither one rotating to face the other because both are tidally locked to Saturn and not to each other. That moment is the moment of the handoff. The exact instant when the gravitational exchange completes and the roles reverse and the separation begins. They do not touch. They do not need to touch. The force that passes between them at 15,000 kilometers is sufficient. Gravity at 15,000 kilometers is enough to transfer the momentum, enough to lift one moon into a higher orbit and drop the other into a lower one. Enough to execute the whole transaction and send them on their separate ways, the smaller one flung wide, the larger one barely stirred, both of them continuing on their path around Saturn as if nothing extraordinary had occurred. Which, from their perspective, if moons can be said to have perspectives, nothing extraordinary had occurred. It was only the swap. It is always only the swap. The 4-year clock resets, and the counting begins again, and the inner moon resumes its slow accumulation of distance over the outer moon, 30 seconds per orbit, day by day, lap by lap, until the next exchange, for billions of years without variation, without a single collision, not because the universe was careful, not because something intervened. Because the system, set up as it was, with the masses it has and the orbital energies it carries and the conserved momentum that cannot be created or destroyed, was never capable of producing a collision. The crash is not a danger that was averted, it is an outcome that the geometry forbids. The two moons are not getting away with something each time. They are simply doing what they were always going to do, which is what they will always do, which is exchange their orbits politely, and separate, and circle Saturn, and come around again. This is what gravity does when you give it enough time and the right arrangement of bodies. It finds its equilibria, it settles into its resonances. It produces stable configurations that persist not because they are protected, but because they are stable, because the forces that would push them out of balance are the same forces that push them back into it, because the self-correcting property of the horseshoe orbit means that any small perturbation is absorbed by the exchange and the system returns to its established pattern. As it has returned, as it will return, on and on through the long future of the solar system. And somewhere in that slow, reliable, endlessly repeated story, there is something available for a person lying awake in the dark, thinking about the things that feel like collision courses, the appointments and the conversations and the decisions that feel. In the particular amplifying quiet of late night, like they are approaching faster than they can be managed, like the gap between now and some moment of impact is closing and there is no good way through. What Janus and Epimetheus have been demonstrating in the orbital mechanics sense for longer than the Earth has had complex life on its surface, is that proximity is not the same thing as collision, that a gap closing is not the same thing as a gap gone, that the moment of closest approach can also be the moment of handoff, when what felt like a danger resolves into an exchange, when the energy that was accumulating in one place transfers to another, when both parties turn away, changed by the encounter, but not destroyed by it, and the distance between them begins to grow again. The system knew how to make it through. It always has. It is built to make it through. And the making it through does not look like a narrow escape. It looks like an orderly exchange conducted at 15,000 kilometers by two lumpy, porous ice and rock worlds in the outer solar system, following instructions that were written into the laws of physics long before either of them existed. You do not have to do anything tonight with the collision course that feels most immediate. It will still be there tomorrow. The approach will continue at its own pace, and the exchange will happen when it happens, and what feels right now like a closing gap may reveal itself in the morning or in the days after, or eventually to have been the setup for a handoff you did not yet know how to see. Janus has been doing this for a very long time. Epimetheus, too. They have no anxiety about the next swap. They carry no memory of the previous one. They circle Saturn at 151,450 kilometers from its center, completing a full orbit every 16 hours and 40 minutes, approaching each other and retreating and approaching again, and they have never once collided, and they never will. If you feel moved to share where in the world you are listening from tonight, I would genuinely like to know. The comments are there, and I read them, the quiet notes left in the middle of the night from people who found their way to this place looking for something to carry them through to morning. There are more stories here, more slow descents into the strange and the old and the quietly astonishing, waiting for whenever you want them. But for now, you have done enough for one night. The thinking can rest. The approaching things can approach at their own pace without your help. The system already knows what to do with them, somewhere out past the rings of Saturn, past the bright A ring with its sharp outer edge that Janus keeps clean, past the faint dust haze that both moons have been building together for longer than words have existed. Two small irregular worlds are circling a gas giant in the dark, separated by less than their own width, taking turns on the inside track, trading places every 4 years, never once touching. The geometry holds. It always holds. Put down whatever remains of the day. Let the dark be easy. Good night from up here in orbit. I'll keep watch while you drift.